Let's imagine that there are 4 positive charges in metal sphere X and Y, as well as 4 electrons in each sphere. Okay, so when the positive rod is being brought near the 2 sphere, the electrons in X and in Y, they will be attracted such that it is closest to the metal rod. So all the 8 electrons belonging to X and Y will be attracted to this position here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now the 2 metal spheres, they are being separated. As we look at metal sphere X, it has got 4 more electrons than proton, so we can say that it has a negative 4 unit of charge. And for metal sphere Y, it has got 4 positive charges left, so it has a net positive charge of plus 4 unit. So in this case, we can say that Y is now positively charged, and the size of the charge is the same as that on X. Answer D. Initially, we have a wire that is 8 ohm. So now we have a second wire made of the same material. Okay, so what is the resistance? If the length is half, as we know that the length is directly proportional to the resistance of wire. If the length is half, the resistance will be half. So in this case, we will take 8 times half to account for the halving of the length. Okay, now the cross-sectional area is twice, and cross-sectional area is inversely proportional to the resistance. So if the cross-sectional area is twice, the resistance will be half. So we will times by half again, and we'll get the resistance of the second wire to be 2 ohm. Answer B. Okay, first of all, we need to find the voltage across the parallel branch. So we can use the formula V is equal to IR, and I is 4, R is 6, so the voltage here is 24 volt. Okay, so since the voltage here is 24 volt, we can calculate what is the current here. Use the formula I is equal to V over R. 24 divided by the resistance, which is 12, we will get 2 ampere. So the current down here is 4 ampere and down here is 2 ampere. So that means the current that passes through the ammeter before it splits into 4 and 2, it should be 4 plus 2 equal to 6 ampere. So the answer should be B. To find out which of the following costs the least, we have to check which of the following uses the least energy in kilowatt hour. So to find the energy in kilowatt hour, we need to change the watt into kilowatt, and we need to change the time into hour. So option A, it will be 5 kilowatt multiplied by 1 over 60 of an hour. So that will give us 0.0833 kilowatt hour. Option B, it will be 1 kilowatt multiplied by 10 over 60 of an hour. This will give us 0.167 kilowatt hour. And option C, it should be 0.5 kilowatt multiplied by 1 hour. We will get 0.5 kilowatt hour. And 100 watt, it will be 0.1 kilowatt multiplied by 24 hours in a day. We will have 2.4 kilowatt hour. So if we look through the calculations, we know that option A uses the least energy. So the answer should be A. Okay, in this question, the first fuse is blown, and when the house owner replaces with a second fuse, it also blows. And the house owner chooses to use a third fuse with a higher fuse rating. Okay, this is not a sensible thing to do, because the reason for the fuse to blow is because the circuit is drawing an excessive current that is higher than the fuse rating. So that means there is a fault with the lighting circuit. So by replacing a third fuse with a higher rating, it might cause the circuit to work, but then the excessive current is still flowing through the circuit, and if it is not corrected, it might pose a danger to the user. So in this case, the answer should be the circuit might work, but the fault is not corrected.